In the vast, windswept expanse of the Gobi Desert, where endless dunes meet the horizon and the silence is broken only by the whisper of the wind, a new chapter in space exploration was about to unfold. Here, China's private space company Landspace prepared to launch its Zhuke-3 rocket, a gleaming pillar of technology and ambition. Their goal, to recover and reuse an orbital-class booster, a feat that only a handful of nations and companies have managed to achieve so far. The stakes were high, and the world was watching. As the engines roared to life and flames erupted beneath the rocket, the Zhuke-3 began its ascent. The launch was flawless, a testament to the precision and expertise of Chinese engineering teams who had spent years preparing for this moment. The rocket soared skyward, piercing the blue desert sky and leaving a trail of white cloud behind. It carried its payload to orbit exactly as planned, marking another successful step in China's growing space program. But the true test was yet to come. The real challenge lay in bringing the first stage safely back to Earth. Could Landspace pull off a controlled landing in the harsh desert environment? High above the desert, the booster separated from the upper stage, then executed a series of complex maneuvers. It flipped, reoriented, and fired its engines, beginning a carefully choreographed descent toward the landing pad below. Balancing gravity and thrust, the booster hovered and adjusted its position with remarkable precision. This delicate dance is one of the hardest feats in modern rocketry, requiring split-second calculations and flawless execution. As the rocket neared the ground, tension mounted. Engineers and spectators alike held their breath, watching as the landing gear deployed and the booster hovered just above the pad. Success seemed tantalizingly close. But in the final heart-stopping seconds, the rocket tipped to one side and crashed, erupting in a spectacular fireball that lit up the desert night. The explosion was dramatic, a vivid reminder of the risks and challenges of spaceflight. Yet it was not simply a failure, it was a powerful sign of progress, a necessary step on the path to innovation. In mission control, the Landspace team watched intently, their faces a mix of disappointment and determination. They had come closer than ever to mastering a transformative technology that could change the future of space travel. Around the world, audiences saw not just an explosion, but a bold step forward for China's private space industry. The attempt captured imaginations and signaled that a new player was rising in the global space race. In the smoke and flames, the spark of innovation burned brighter than ever, illuminating the path for future missions and inspiring engineers to push the boundaries of what's possible. Landspace's daring attempt marked not just a setback, but the dawn of a new era for China's space ambitions, one defined by resilience, ingenuity, and the relentless pursuit of the stars. The Zhuke-3 mission was truly a tale of two halves, each with its own challenges, triumphs, and lessons. On one hand, it was a demonstration of cutting-edge engineering and ambition. On the other, it was a reminder of how difficult and unpredictable spaceflight can be. The launch itself was a resounding success. As the rocket's 9 engines roared to life, the vehicle surged off the pad, climbing steadily into the sky. The world watched as Zhuke-3 soared upward, its powerful engines working in perfect harmony to propel it into orbit. This flawless ascent was a testament to the rocket's design, the expertise of its engineers, and the reliability of its systems. Every stage of the launch was executed with precision, proving that Landspace could build a world-class launch vehicle. But the real drama began after stage separation, when the booster's journey back to Earth took center stage. The booster executed a series of complex maneuvers, flipping itself around in the thin upper atmosphere, surviving the intense heat and forces of re-entry, and then steering with remarkable accuracy toward the designated landing zone. As it approached the ground, the final landing burn was the ultimate test of both hardware and software. The engines fired in a carefully choreographed sequence, aiming to slow the booster for a gentle touchdown. For a brief, heart-stopping moment, everything seemed to be going perfectly. But then, an unexpected engine anomaly caused the booster to lose stability, tip over, and crash dramatically onto the landing pad. Despite the fiery explosion and the loss of the booster, Landspace declared the mission a partial success, emphasizing the progress made and the valuable experience gained. The true objective of the mission was data collection. Every second of flight, every maneuver, and every anomaly was meticulously recorded for later analysis by the engineering team. In the world of spaceflight, even a crash landing is a valuable lesson. Each failure reveals new information, helping engineers refine their designs and improve future missions. The explosion was not the end of the story, but a crucial step forward in the journey toward reliable rocket reusability. With each attempt, China moves closer to making reusable rockets a routine reality, paving the way for a new era in space exploration and technology. For decades, rockets were designed for just a single journey, massive, complex machines that were used once and then discarded, often falling into the ocean or burning up in the atmosphere. This made every launch incredibly expensive, as each mission required building an entirely new rocket from scratch. The result? Space exploration was limited to only the most critical missions, and the dream of routine access to space seemed out of reach for most. Reusable rockets have completely changed the game. These innovative vehicles are designed to launch, land safely back on Earth, and then fly again, sometimes within days. By recovering and reusing the most expensive parts, companies can dramatically reduce the cost of each launch, making space more accessible than ever before. The first stage, which contains the engines and most of the hardware, is by far the priciest part of a rocket. Saving and refurbishing it after each flight means that launches become not only more affordable, but also more frequent and reliable. Lowering costs opens up a world of new possibilities. We can now launch vast constellations of satellites to provide global internet, send up science missions more often, and even make space tourism a reality for ordinary people, not just astronauts. Reusability is absolutely essential for our biggest ambitions, like building permanent bases on the moon, where supplies and equipment will need to be delivered regularly and affordably. And when it comes to sending humans to Mars, reusable rockets are the only way to make such long-term, interplanetary missions possible. Only a large, reliable fleet of reusable rockets can support the frequent launches needed to build and sustain outposts on other worlds. These rockets are quickly becoming the backbone of a new, thriving space economy, one where launches are routine and space is open for business, research, and adventure. Mastering reusable rocket technology isn't just about saving money, it's about unlocking the next era of human achievement, making space accessible for future generations, and building a sustainable future beyond Earth. Reusable rockets are the bridge to a future where humanity becomes a truly multi-planetary species, exploring and settling new worlds. The race to perfect this technology is transforming the space industry and shaping the destiny of our species among the stars. Landspace's fiery setback is part of a well-trodden path. SpaceX, the pioneer of reusable rockets, endured years of spectacular failures before success. Each explosion was a lesson, not a disaster. Data was gathered, problems fixed, and attempts repeated. Blue Origin 2 has faced setbacks with its New Glenn rocket. Even experienced teams struggle with the leap to orbital-class reusability. Landspace's experience mirrors these pioneers. A crash is a sign of progress, not defeat. Landing a booster is like balancing a broomstick in a hurricane, an immense technical challenge. Coming close on the first try is remarkable. Every failure is a step toward routine, reliable rocket recovery. The journey is explosive, but it's the only way forward. The Zhuge 3 is a leap for China's commercial space sector. At over 76 meters tall, it's built for reusability, with stainless steel tanks and methane engines, modern choices for rapid turnaround. Methane burns cleaner, making engine reuse easier and faster. Its 9 engines can lift over 21 ton in year, then also dender dictionside a ton and cider do during my tonnets to low Earth orbit. Landspace aims to reuse each booster at least 20 times, slashing costs and boosting competitiveness. The rocket's versatility suits both large satellites and constellations. Landspace's earlier success with the methane-powered Zhuge 2 paved the way for this larger, more ambitious vehicle. The rapid development from ZQ-2 to ZQ-3 has caught global attention. China is now a serious contender in the global launch market. In rocketry, failure is part of the process. The Zhuge 3's explosion yielded a wealth of engineering data. Real-world tests reveal flaws that simulations can't predict. Landspace now knows where to focus, perfecting the final landing burn. Rapid, hardware-rich testing accelerates progress far faster than cautious, paper-only design. Each flight, even a crash, is a step up the learning curve. Private companies can take risks, learn fast, and innovate quickly. The fiery failure was a leap forward for China's space ambitions. For China, reusable rockets are a strategic necessity. Massive satellite constellations and ambitious space projects demand frequent, affordable launches. Landspace and other private firms are racing to deliver, spurred by government support and fierce competition. This mirrors the US model, where commercial innovation drives progress. A reliable Chinese reusable rocket would reshape the global launch market, driving down costs and increasing access. The new space race is global, with China emerging as a major player. Each attempt, success or failure, pushes the boundaries of possibility. The era of a single dominant space power is ending. With every launch, China, and humanity, moves closer to the stars.